Hello everyone, welcome back. So now in this video we are going to learn about rules to draw ray diagrams. So why these rules are meant? See, light coming from an object will travel in different directions, right? So the incident on a mirror in different points, sort of which each and every person might take their own ray diagram, or you can say a light ray. So to remove that ambiguity, we are just introducing some few rules, sort of which everyone have to follow basically these rules only to draw the ray diagrams. Okay now? So we will start with rule number 1. Okay? So rule number 1. So for this, let us have a mirror and then statement. Clear? So I would like to draw the spherical mirror now clearly. That spherical mirror, first one we are discussing about concave spherical mirror. We are discussing about first one is concave spherical mirror. Say this is your assume concave spherical mirror, and now I would like to silver the spherical mirror. So to say that this is a concave spherical mirror, we need to silver it on the bulged part. Very good. So on the bulged part of this surface, if we silver, this turns out to be a concave spherical mirror. So now I just assume, and what is the second step we need to do? The second step you have to do is to draw the principal axis. So this is your principal axis, and the principal axis readily passes through. Already we know that the first point it would pass is the pole, and the next point it would pass is center of curvature. And already we know somewhere in the middle we will be having a principal focus F. Clear all of you? So this is your basic diagram which you have to follow for the things over here. So I would like to take the reference of this one for the next rule too. So therefore now see here, in this kind, the rule number 1, what does rule number 1 state is, see here, any light ray, directly I would like to say, any light ray passing parallel to principal axis. Okay now, I hope you can understand this. Passing parallel to principal axis, I am writing in short. After reflection, okay now, after reflection, because it hits the spherical mirror, it passes through. So the reflected ray passes through focus. So this is your first rule. So let us draw the rule number 1 diagrammatically. See here, any light ray, as said above, passing parallel to principal axis. The light ray has come parallel to principal axis. After reflection, what happens it seems? It straight away passes through focus. That's it. So according to this rule, any light ray passing parallel to principal axis, after reflection, it goes through focus. This is your rule number 1 for your concave mirror. Sir, only the above light ray you have taken. Why not we can't take a below one more light ray? Yes, you can take. It is your choice. Any number of light rays you can take parallel to the principal axis. These after reflection here in this diagram will go through focus after reflection. Clear? So this is your rule number 1. And next let us go to rule number 2. So let us see the rule number 2 now. So the same diagram we are just considering. So for our easiness, done. So let us take the statement first. So any light ray, I can say directly this one, opposite of the rule 1, passing through focus, any light ray passing through focus, after reflection, what happens? Opposite to rule number 1, right? It goes parallel to principal axis. That's it. So as I said, it is opposite to rule number 1. So in rule number 1, light ray is coming parallel to principal axis and it is going through focus. Now here the light ray itself is coming through focus. See here like this. So when a light ray is coming through focus, so after reflection what happens? It goes parallel to principal axis. So even you can assume one more light ray downward also. It is your choice. So light ray passing through focus after reflection goes parallel to principal axis. Here also you can say light ray passing parallel to principal axis after reflection goes through focus. Either of the case you can consider, no worries at all for this. Okay, na? Right. And the next one is rule number 3. The next one, rule number 3. Fine. Let us take the concave mirror first for rule number 3. So silvering on the bulged part will give you concave mirror. And the very next step what you have to do is to take the what you call principal axis. Yeah, very good. You are repeating it. Fine. And thus, there the point on the spherical mirror that acts as center, geometrical center is called as pole. And this one acting as your center of curvature. And over here is focus. So let us see the rule number 3 now, everyone. So rule number 3. What does rule number 3 says is that any light ray, okay na, any light ray passing through center of curvature. Straight away I am saying it is passing through center of curvature. So already we have experienced this point once previously. What is that? A light ray passing through center of curvature and any point on the principal axis acts as a normal, right? So the same thing here, any light ray passing through center of curvature, after reflection, it retraces the same path. Why, sir, it retraces the same path? Because any line passing through center of curvature and spherical mirror, any point on spherical mirror, already we know that it acts as a normal. So now the light ray itself is incident on the normal, means angle of incidence is 0, so angle of reflection also will be 0. As a result, the light ray will retrace its path. See, a light ray incident through the center of curvature, see like this. So passing through center of curvature, what happens now? So this is the incident ray direction. It is passing through center of curvature. So after reflection, it goes along the same path. So it retraces the same path. The reason here is angle of incidence is equal to 0 degrees and angle of reflection is also equal to 0 degrees. Since incident on normal. Since incident on normal. That is the reason. Nothing more than that. Clear? Right. And the last but not the least, rule number 4. So once again, consider a spherical mirror. That is your concave spherical mirror. So done. We have just assumed a concave spherical mirror. And then let us silver this one. Outer edge. So that we will get a concave mirror. And as and if based on our tradition, what we need to take? Principal axis. As it is an assumed to be an imaginary line, we are just saying it is in a dotted form. And now it exists a pole geometric center, and there exists center of curvature, and there also exists focus. So what is rule number 4? So directly, any light ray, this is based simply laws of reflection. Incident at pole, any light ray, incident at pole making an angle theta. So that is your angle of incidence. What was he saying? Theta, making an angle theta. It reflects with same angle theta. That's it. So this is nothing but your angle of incidence is equal to angle of reflection. So simple. So if any light ray incident at pole making an angle of incidence is equal to theta, as we already know that angle of reflection will be same as angle of incidence, it also reflects back with same angle of reflection, that is theta. So what is the reason you can say? I is equals to R. So these are your 4 rules to draw the ray diagrams for your concave mirror. So according to rule number 1, any light ray passing parallel to principal axis after reflection, it goes through focus. And rule number 2, any light ray passing through focus after reflection goes parallel to principal axis. And rule number 3, any light ray passing through the center of curvature after reflection, it retraces the same path because it is assumed to be incident on the normal. For the incident, light ray incident on the normal, angle of incidence and angle of reflection are same, that is 0 degrees. And rule number 4, any light ray incident at pole making an angle theta, that is your angle of incidence, it again reflects with same angle theta because angle of incidence is equal to angle of reflection. So these are the light rays assumed to be coming from an object where later they meet directly or meet on extension to form a image using a spherical mirror. Hope you all understood. In the next video, we will be seeing the rules to draw ray diagrams for convex mirror. Thank you all. Have a great day.